Okay, here's what we're going to be working on today. This is our next lesson in inference for means. We're dealing with two sample intervals for a difference in means. So what we're going to be doing is we're going to be taking a look at some data, and we're going to be determined if what the interval of the potential differences between two means are. It's very similar to what we did with proportions, except again, that one check that we're going to deal with, the large enough check changes, and the formula slightly changes. So let's read through and kind of pull out the information we need. So as I read through this problem, I see most recent American time use survey conducted by the Bureau of Labor Statistics found that many Americans barely spend any time reading for fun. People ages 15 to 19 average only 7.8 minutes of leisure with a standard deviation of 5.4. However, people age 75 and over average 43 minutes with a standard deviation of 35.5. So now what's going to happen is these results were based on random samples of 975 people age 15 to 19 and 1,000 people age 75 and over. So now what we're actually going to be looking at is we're going to see, is there a difference between those two? Is there a difference between the teens and the older? So what we're going to do is we are going to go ahead and follow that same process. P is going to be our parameters. So the first one is mu t equals the true mean amount of time that people age 15 to 19 read per day. T for teen. And we're going to say for this one, mu, and I don't want to do older, let's do S. So we'll do the true mean amount of time that people aged 75 and over read per day. And what we're really honestly interested in is we're actually interested in this mu t minus mu s, which is the true difference in means. Okay, so that's what we're going to be looking for. We're going to be looking at that true difference in means. So again, when I look at this, what's happening is, share went down. We're caring about the difference between the two. So again, still nothing about the sample. We're going to hold the sample off for a while. So then we're going to do A. So now what ends up happening with A is we're going to validate our assumptions, and we need to do it for both. So in this case, we're going to check random, and it says random for both. So states random for both. Okay, now what we're going to do is we're going to check our independent. And when we check our independent, that's the 10n check. So we need to do it for both. So I'm going to do 10 times, in this case, the 975. That equals 9,750. We're comparing that to the population of teens. And then we're going to do 10 times 1,050. So that's 10,500. And we're going to compare that to our older folks. And what we are going to say, that it's safe to assume more than 9,750 15 to 19-year-olds and 10,575 plus year olds. And we can also say the two groups are independent of each other. Independent of each other. Okay, so far it's pretty much just like we did in proportions, except like, again, we have the new symbol. We're using mu instead of p, but the checks are the same. So now, large enough. Here's where we have a different check. We do not check for 10 successes. We do not check for 10 failures. What we are checking for is we are checking to see if the population is normal. In this case, it says nothing about the population being normal. The next thing we're going to check is we're going to check sample sizes. Well, sample size of teen is 975. That's greater than or equal to 30. the sample size of our 75 plus is 1,050. That's greater than or equal to 30. We can say by central limit theorem, we can say that the shape is going to be approximately normal. We actually can conclude that because of the central limit theorem. So that's a new check. So again, we don't check successes and failures. We only check population first, sample size second. If it's big enough, we're allowed to say, yeah, normal by central limit theorem. If it's not, then we got to look at a picture. So in this case, we got kind of lucky. We had the central limit theorem. So N, we're going to construct a 2-sample T interval for true mu T minus mu S at 95% confidence. And here's where I'm going to go and I'm going to grab the formula sheet. The formula sheet. Okay, in the formula sheet, what we're going to do is we're going to go ahead and we're going to look at the infinity row on the formula sheet. And I lost my formula sheet, so I'm going to pause this while I find my formula sheet. Okay, back on the formula sheet. So we're going to go back and look at the information again. So here is how we figure it out. Our sample size for teens is 975. So the degrees of freedom for teens are going to be 975 minus 1. So it's going to be 975 minus 1. (975 minus 1). So our degrees of freedom here are going to be 974. And then our degrees of freedom for our older folks, 10,050. So our degrees of freedom for our older folks are going to be 1,050 minus 1. So now here comes the deal. We're going to take a look at our degrees of freedom, and our degrees of freedom is we're going to kind of look and see 95% not in there. So what's going to happen is when I look at this, I end up with 974 for the teens, and I end up with 1,049 for the older folks, or for the 70 plus, 1,049. And what's going to happen is, based on this degrees of freedom, I'm going to look and see in the calculator what is the lower of the two in this case. So in this case, 1,049, I would take 1,000, so that'd be 1962. But the teens would be 974, rounding down would be 1.984 down here. So I have two different ones. I'm going to take whatever has a smaller degree of freedom. So in this case, I'm going to take the 1.984. So what I'm going to use for my T star here is 1.984. What you're going to find out is in the calculator, it's going to give me a combined degrees of freedom. I can reference that, but what I want to let you know is in the case right here, when I'm writing out the formula, I'm going to use the smaller of the two. So now here is my interval. My interval is going to be the following formula. It's going to be x bar 1, so our x bar teens minus x bar 70 plus or minus T star, the standard deviation of teens over the square root of the sample size of teens. It's the standard deviation squared of teens over the square root of the sample size of teens. We got our older folks standard deviation squared over their sample size square root. So again, this is on your formula sheet, but what's really important is to write this down with the numbers plugged in. So in this case, what I'm going to do is I'm going to go ahead and say 7.8 minus 43.8 plus or minus 1.984 square root of, and it's not square root down here, I'm sorry. My mistake, made a mistake. It's not going to be square root, it's just going to be the plain one. So MT and NS. So now I'm going to plug in my numbers. So it's 5.4 squared over 975 plus 35.5 squared over 1050. And then what I'm going to do is I'm going to grab my calculator. My calculator is going to do all of the heavy lifting for me. The way I'm going to do it in my calculator is I'm going to do stat. I'm going to do tests. What I'm going to do is I'm going to go to number 0, which is 2 sample t interval. I'm going to put in the stats. And in this case, the stats are my first mean, 7.8. My first standard deviation, 5.4. My first sample size, 975. My second mean, 43.8. My second standard deviation for the older folks, 35.5, and then my sample size, 1050. My confidence level is 95. We are never, ever, ever going to say yes to a pooled question. The only time we're ever going to pool, the problem's going to do it automatically. When I hit enter, I want to show you what it's going to calculate. It actually gives you a range of values. So in this case, it's going to give me the range of values of negative 38.18, comma, negative 33.82. Now, the other thing I want to show you is it actually gives you the degrees of freedom from the calculator. So in this case, what we want to do is if we are going to plug in this number here and this number, what we want to do is reference the degrees of freedom from the calculator. And we want to say that this one actually used the degrees of freedom in the calculator of 1,101.2. That's where that came from. So what I want to do is I actually want to tell the person reading it that, hey, this is the formula I used. I came up with a conservative degree of freedom, but this is what I'm going to give you my answer as. And then my final step is going to be to state my conclusion. We are going to say we are 95% confident the interval from negative 38.18 minutes to negative 33.82 minutes captures the true, and we're going to copy right from up top here, difference in mean amount of time that people 15 to 19 and people 75 plus read per day. And if I needed to make some sort of interpretation on the context of this, would you be surprised? Do you believe that older people read more than younger people? Well, based on this interval, look for the number 0. And if you notice the number 0 is not in the interval, it actually is all negative. So what this would imply to me is that I could draw a conclusion that 75 plus year olds actually read more on average than teens. So again, if you think about it from the concept of what we've done before, again, let me just kind of show you the differences. The references, the notations change. We're now dealing with mu's instead of p's. The large enough check changes. We're dealing with a t interval. We're going to deal with a t star. Our formula is different. The calculator button is different, but in essence, the whole process is the same. So here is what I need you to do. I would like you, if you weren't here for class, I'd like you to go ahead and take a look in this folder. There's an actual practice. I want you to go ahead and give the practice a shot. So if you weren't here, I want you to give the practice a shot. I want you to complete it, bring it to class next time, hand it in so I can see that you watched the video. I can see that you tried the practice. If you were here, I'm giving you time in class to work on that. So that's going to, again, be collected just to kind of show if you have that handle on it. Please take advantage of after schools and SOARs if you have any questions.